All right. Structure of a confidence interval. This part is on your formula sheet. This is a statistic plus or minus the critical value times the standard error of the statistic. Now, my point for this is going to be that, for instance, if I'm trying to do a confidence interval for P, singular, one, the proportion of one population, my statistic would be P hat plus or minus, what's my critical value?
Z star.
Z star times the standard error of the P hats. In this case, what we would use is P hat 1 minus P hat over N, because we don't have P, nor do we have a hypothesized value for P. What is my statistic if what I'm doing is comparing the proportions for two separate groups?
P hat 1 minus P hat.
It's the difference between two different P hats. What's my critical value?
It's still Z star.
It's still Z star. Done the exact same way. How do I find Z star? Inverse norm. And then my standard error formula gets a little bit messier. However, guess where you can find this? On your formula sheet. So your formula sheet doesn't give you each of these individually. It gives you the structure, but that doesn't mean you couldn't use it to get there. This is a 1 sample Z interval. This is a 2 sample Z interval.
Wait, what did you just say?
This one is a 1 sample Z int for P. This is a 2 sample Z interval. Now, a mistake that y'all really liked to make is you would say for P. That's not what you're estimating there.
For P1 minus
It's for P1 minus P2. It's for the difference between two populations. So 2 samples needs to describe 2 parameters. Okay? And when we describe those parameters, we might say P1 equals the true proportion of blah, 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 blah. P2 equals the true proportion of blah, 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 blah. But we're going to define those. We're going to use the word true as part of our answer. Everybody good?
1 sec.
Why? Why is it doing that? She's always listening.
Because she is always
That was
listening.
weird.
Like, how else would they know when you say, hey, Siri?
Also, the ads I get changed based on what I've been saying recently. Yeah.
That always happens.
Wasn't there a whole privacy thing if they wanted to do that with billboards too?
With what?
How would they do that?
How they do billboard.
Like it would be personalized to you, like as you're in proximity of a billboard.
That'd be crazy.
Well, that's why it was an issue, because the personal information.
It's like
that's
a
what you
different,
do
like, it
that.
changes within 2 seconds. It's a brand new.
How would they
That'd be crazy.
Brand new one.
I wouldn't. Yeah.
Well,
Well,
that was
it
a
wouldn't
thing.
function.
Hmm?
How would that,
There
like,
are 2 cars next to each other driving past the building.
No,
yeah,
but
how would that work?
how-
It would be the
Oh,
general.
there. I would imagine they would track the metadata enough to know where was it like successful, and go to the people who are more like. For instance, if they know from my phone that she's way likely to buy something from an ad on Instagram. Totally true. Okay, then maybe they'll flash it for me versus somebody else who they know never buys things off of ads.
And then they could probably like generalize the data and be like, oh,
That'd be sweet.
they could be like, she's
like,
a
based on, like, photo, that's like
teacher,
like,
and then
but
flashes
they're
an
not
ad
even
for
what you
like.
want.
All right, X bar plus or minus for a 1 sample T interval for mu, right? This time it's going to be a T star, and we're going to use the standard deviation of the X bars.
One sample t-test.
Nope, T.
Wait, what's the columns thing again? That's ranges at?
Two base table. It's columns minus 1 times rows minus 1. And that's like excluding the total row.
This for this one, it's N minus 2. for these ones. But in reality, again, for the 2 sample t interval, when you run it on your calculator, it will do a fancy formula. You'll get this long decimal thing, and that's fine. Hey guys, when your calculator asks you for pooled
Just
or
always say
unpooled,
no.
you always say
No.
no.
What does pooled mean?
Doesn't matter, let's not
Don't
waste
worry
our
about
brain
it.
space on
Let's
it.
not get
Yeah.
You're welcome to ask me that next week.
Next week.
Or don't, but.
What are we
Next week.
What's about the AP test?
You guys are going to be doing, I think, it's going to be pretty laid back, but I think I'm going to have you guys work with Mr. Hinkle,
Wait, have we made the final decision?
Sample.
Mr. Belk.
Okay, that's
Yeah, that's the second choice.
Yeah.
Yeah.
It was,
The guy who wants
We
to be
ranked
there.
them because we were together at the time. And
Got
like,
it.
Yeah.
Got it. Because overall, he was the student's first
He
choice
was, yeah.
by a decent amount of separation.
Mine
Ours was
was
Brian
more.
Moore. But the teachers really didn't like him, so.
That's
We're
not,
back to
Well, like,
I
we
had less of
heard-
a 1
we
and
heard
2
that
and
the
more of like
teachers
a
didn't
really
like
big
him.
3 that I didn't like.
Yeah.
good to know. Um, anyway, all right. What else about confidence intervals? All right, for tests.
Or wait, what are the conditions?
Well, the conditions are kind of the same all the way through, so we'll talk about that. Like, for tests, some big ideas for tests. I'm going to start a new page here. Tests. Okay. P-value. Tell me anything you guys remember about p-values.
Alpha, you said an alpha, and if the p-value is lower than the alpha. then
Okay, so if you have p is less than alpha, we reject H0. If p is greater than alpha, we fail to reject H0. Why?
Because it's probable, or like it's
It's the likelihood
statistically
of getting
likely.
that sample when HO is true. So if you have a very low p-value, then the probability of getting that sample when the null hypothesis is true is extremely low, meaning that you can reject the null hypothesis.
Okay.
It could happen.
If your p-value is greater than alpha, okay? Remember the whole premise behind all of this, all of it is, when we get our sample, what do we know? What's the most important thing to remember about a sample?
We assume the
Samples aren't perfect.
Samples aren't perfect, okay? Period. So let's say I have a null hypothesis of mu equals 15, and an alternative hypothesis of mu is less than 15. Okay? And I get an x bar of 14.28. Does my sample suggest that the alternative hypothesis could be true?
Yes.
It's some evidence against it. Okay? Is it convincing evidence?
No.
We don't know.
There's a whole lot of things I'd want to know, right? For example, how big is this sample? Like if I tell you that this is 1,000, that could mean something. Okay? How spread out is the initial population? Okay, so let's go ahead and say these are supposed to be the lengths of screws that are supposed to be exactly 15 millimeters long. You would hope that the length of screws is not very spread out. You would hope that they almost always come back as, so 14.28 would be a lot in terms of millimeters on a screw. Money in a bank account? Maybe not as big a deal, okay? So what we do is we say, we don't think about this strictly be with the 15. We take everything into consideration. We say, what is the probability that we could get a sample mean of 14.28 if the actual mean is 15? And if it's reasonably likely that that could have just happened by chance, then we don't accept that the null hypothesis is true, but we're certainly not going to reject it. Everybody good? All right. Some other things worth considering about tests. Type 1 and type 2 error. How are we feeling on type 1 and type 2 error? I feel like I bring it back a lot. That's one of the topics, okay? All right, I'm going to say this next one. And don't worry, I already know your answer. How are we feeling about power?
Okay.
Oh,
The
increase power
the
and
probability of the test to
increases-
correctly, to make the right decision when the alternative hypothesis is true.
Yeah, but it's going to be like a very specific thing. So here's how you're going to get asked about power. So let's go ahead and say that this test, the power to detect mu equals 13.5 is 0.57. What does that mean?
Given that the true means.
If the true mean is actually 13.5, what's the right decision of the test?
Fail to reject.
Fail to reject because null hypothesis is true. Oh wait, in that context, in that
we would
context.
reject null.
No.
So the right decision is to reject the null. Okay. Now, does that mean, because this is, by the way, this is HA is true, yes?
Yeah.
Does that mean the sample I gather is going to be one that's going to make me reject the null?
I mean, with that high of an end, you could maybe.
That's not very much.
Yeah, think.
Well, with that high of an n, yes. But like in general, is it possible I get a sample where this is true that's like 14.8?
Yeah.
And then I might not reject the null. Do you guys see what I'm saying there? Okay, so the probability that I get a sample that will make me reject the null is 57%. If the true mean is 13.5. If this is what's true, this is my probability of correctly rejecting the null hypothesis. By the way, if mu is equal to 13.5 and the alternative hypothesis is true, what kind of error could I make?
Type 2. Type 2.
Type 2. Okay? So if I make the wrong decision, I'm making a type 2 error. If I make the right decision, that's power, yes? So in this context, what is the probability of a type 2 error? 0.43. Are we good with this?
Wait, which is 0.3?
So the power is the probability of the sample is correct, basically.
The probability of type 1 is 0.43.
Yeah, because 1 minus.
No, the probability of type 2 is 0.43.
Because 1 minus.
Because type 1 is the
57.57.
is alpha.
Yeah, okay.
And alpha and power are directly proportionate, right?
Or is that
I don't like that word at all. But they move, alpha and power move together. Because alpha, getting bigger means you reject more frequently. So in the power graph, you're rejecting more frequently means you're increasing the probability of the right decision if the alternative is true.
Yeah.
Okay. Now, what you guys have all been waiting for. Conditions.
Yes.
Let's talk about conditions. Here's the deal about conditions, y'all. You don't want me to talk about all of them. You actually only want me to talk about one condition. You want me to talk about the normal condition. Because here's the deal.
Yeah.
I thought you meant only talking about some tests.
No. How many of you feel confident that you can check the random condition? How many of you feel confident that you can check the independent condition? So am I right that you don't want me to talk about everything? I'm fine with talking about normal condition.
Can you also talk about some more the like LSS?
So normal and LSS are essentially the same thing.
LSS is less than or
pi
equal to
squared,
5,
it's
right?
greater than 5.
Greater than
Greater
5.
or less.
Okay? Both of these are basically saying that your sample size is large enough that it's going to follow the right distribution. Okay? Large sample size is necessary for chi-squared. okay? And that is that all the expecteds has to be greater than or equal to 5. I promise you the number one mistake kids make on that particular thing is they try to make all the observed counts greater than 5, not all the expected counts. Are we good with that? But both of these is essentially my sample size is large enough that we don't have too much chance variability in the sampling distribution. Okay, so let's do means first. The normal condition for means, whether it be 1 or 2, my sample size has to be greater than or equal to 30, or no major skewness or outliers. If they don't give you the graph, you draw the graph. That being said, it is unlikely that you'll have to draw the graph. It's not that it's never happened. It's definitely happened. But like typically they'll give you any graphs that you need to draw. If they give you the graph, don't draw it, just refer to the graph that they give you. What becomes really important is as you refer to a graph that you do so as specifically as possible. So don't be like, oh, the graph shows no major skewness or outliers. Say, oh, the dot plot of blah, 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 blah.
Is this for intervals and tests or just intervals?
Yes.
Okay.
All right. Then we got the p-hats. And for the p-hats, it's all over the place. Okay. For intervals for the p-hats, and this is actually true for both, okay? For intervals, it's n p-hats and 1 minus p-hat. Or n1 p-hat 1 and 1 minus p-hat 1. Like it's just you just use p-hat to do this, okay? And they have to be greater than or equal to 10. For tests. We assume the null is true, yes? Because we're assuming the null is true, we use the P from the null hypothesis.
Wait, so can you give an example of a question that would use it like this? Like with, like that,
Sure.
they would
And
use
these would
the
be,
null?
and these are ones using Z star, right?
No, Z.
Oh, this one's using
Z, not Z star. Because these would use Z star. These would use a Z statistic. Okay. So for instance, let's say my null hypothesis is P equals 0.25 and my alternative is P is greater than 0.25. And I get my P hat is equal to 33, or apparently 35 out of 110, whatever that is. .318. Okay. If I asked you to do the interval, you would use this. If I'm asking you to do a test, you would do this. You would use that P that's your hypothesized value for P. Okay? Everybody good? There's one more we haven't talked about.
Is that the combined?
If it is a 2-sample test, okay, your null hypothesis becomes P1 equals P2, that they have the same proportion. And so then you want to look at it as for figuring out which P you use for the condition, you use the combined proportion. So it would be N1 P hat combined, N2 1 minus P hat combined. Wait, N1, N1, N2 P, like you're still checking it for both samples, but you use that combined P hat to get there. That being said, y'all, this distinction is not worth getting bent out of shape over. It's not where I would necessarily spend my time unless I was feeling very confident everywhere else. What are my conditions for tests for beta?
Oh,
Liner.
Liner. Okay. That is the most recent thing we learned. How are you guys feeling about that?
Pretty good.
Not bad.
Okay, so you have independence, random,
no.
normal, which is
One's like
The graph of the residuals is approximately normal.
no
E
fanning
is
in the
that there is no
residual
patterns in
plot.
the residuals.
There's no
No,
fanning in the
that's
residual
fine.
plot.
And linear is no.
No pattern in the residual plot. It's
I remember
random.
random.
Is there, can we just say E? Because I would write down minor.
E stands for equal variances. Equal variances. If you said like equal variability, they would know what you meant. I think you would get away with it. Like, because the big idea is that the line remains the same level of predictor all the way through.
But
Okay.
what do you think the likelihood is that we're going to have to run a test for this on an FRQ?
For beta,
Yeah.
less than 1%. For slope, I don't think it's going to be a free response question. And in fact, it's so minor that I wouldn't be shocked if they did it as like a question 6, as that like thing you're not supposed to know, even though you are supposed to know it.
Okay,
Fresh in our mind.
What else? I guess we could talk about this paired versus two sample.
Yeah.
That one question.
That one question on the exam that you, or the final that you guys were like, I hate you, Miss Meister.
Oh, yeah.
You were. I mean, you were pretty irritated with me. Big idea is paired data is like, just because like that one multiple choice question that you guys are talking about, that was like, which of the following shouldn't be paired data? I'm not saying that like, oh, you want to compare income for a married couple. Okay? That feels like it shouldn't be paired because they're two separate people, but there is a relationship between incomes in married couples. Like there is a relationship because people typically marry people with similar educational levels and stuff like that. Like those are things like, now, not everybody, but statistics is not about individuals. Statistics is about looking for patterns within groups.
But couldn't you talk about confounding variables given like a pay gap or something like that? If they were talking about that.
I mean, are there confounding variables? Of course, which is why we wouldn't conclude a cause-effect relationship there, but that doesn't mean there isn't a relationship. We still look for correlation even for things that aren't causation.
For paired, isn't it only for a paired t-test though?
Well, so the question is, you have to decide, should you be doing a paired t-test or a two-sample t-test?
Yeah, but then why did you write down Z?
That's a
That's a 2.
Oh,
That's
See,
a
has
2.
the line
that makes
across.
me.
Yeah, that's why I always cross my Z's. Always, for that exact reason. Yeah. There. I think my clarifying just made it worse, though, to be honest.
No, it's better.
Test for.
Or interval. That's why I didn't,
It could be a pair.
There's a certain free response question. I can't remember the precise thing. It was like, do men versus women pay more for cars? And I want to say this was on your guys' test over this.
Oh my god, wait, there was one that everyone was really confused about. Where was it?
There was like plans.
Yeah.
So imagine I have model A, model B, model C, model D, model E, model F. And no, that's not what this was. And so then what you were given was what the average for women was, what the average for men was, and then the difference of those averages. Okay? And so,
because you have multiple, because it'd be a linear, what it would be.
That's still
That's why it couldn't be chi-squared.
two sample, right? 'Cause they're
I know,
they're two
but
different
I'm just saying that like this setup looks like a two-way line,
Tampa.
it's
Yeah.
a chi-squared,
What's
doesn't it? Because it's a mean, you would know that it would be it.
Alright.
also important to know that
What
you
overall
back
is it?
off one point.
And
Don't say paired, but you do everything else right.
but well, you won't do everything else right
So,
because there is a difference in how you would go about doing it. Shoot, this isn't what I thought it was. That's what I want.
It's show hate in. Oh yeah. Or you think one goal. It's just Cedric Mullins.
2014, number 5. I want to show you guys this anyway. If you Google the AP Statistics exam, the first thing that pops up is this. Okay? And you can like go to past exam questions. I said 2014, number 5, right?
Yes.
I can go down and click on 2014.
Whoa.
Click on the free response questions. And here are all of them. So here's the example I'm thinking of. Okay? And so the question is, they did the difference men minus women. And when they gave this to kids, they gave you 3 graphs, the women's, the men's, and the differences. And you were supposed to do a paired t-test here. But they gave you all the information to also do a 2-sample t-test.
That doesn't seem, but how is that a pair, because they're using the same card? Okay.
So how is that set up differently?
I'm sorry?
How is that set up differently? How that like one, like paired and one sample is the same?
Yeah. But what people did is they did a 2-sample using these 2 means instead of a paired using this 1 mean. And you get a different p-value and everything.
That seems mean.
Anything you guys in particular want me to have